Let's take a look. Let's take a look at the sampling distribution of the sample proportion, which is p hat. So let's say a survey was conducted in 2006 and found that 10% of Americans were afraid to fly. Now we have a recent study of 500 Americans, and we find that 55 of those said they are afraid to fly. This question says, explain why this is not necessarily evidence that the proportion of Americans who are afraid to fly has increased. I'll tell you how we're going to do that. Let's first answer the question, part A. Is the sampling distribution of the sample proportion, p hat, is it approximately normal? Well, we have to check these two conditions. So we're going to do n times p, these are given values, times 1 minus p. And we're going to check and see what that value is. And this comes out to be 45, which is greater than or equal to 10, so we're okay. Our sample size is 500, and that is definitely less than 0.05 of the hundreds of millions of Americans that we have. So we're okay there too. Now let's compute the mean of p hat, which the mean of p hat is p, which in this case is 0.10. The standard deviation of p hat is the square root of p times 1 minus p over n. And I'm going to just leave it like that. I don't want to calculate it and approximate a value. It's much easier to leave it like that, and we're going to put it in our calculator that way. Now, if we want to find out if this is evidence that the proportion has increased, let's find out what the probability is that of getting what we got or more. We got 55 people out of our 500 who were afraid to fly. Well, we need to convert this value into a p hat value by taking this value of x and dividing it by n. And if you do that, you'll get the probability, we want the probability that p hat is greater than or equal to 11% or 0.11. And we will use normal CDF. We have just justified in part A that the sampling distribution of p hat is approximately normal, so we can use the normal curve. Our lower bound is 0.11. Our upper bound is infinity. Our mean, we just said, was 0.10, and our standard deviation is this square root value that I had earlier. And I'm actually going to type all of that into my calculator. Before I do that, I'm going to show the normal curve here. Here's our 0.10 mean. We're looking at our value of 0.11, and what we're finding is this area in the tail. That is the probability of getting a p hat value greater than or equal to 0.11. Okay, so now I'm typing this into the calculator. And again, I'm typing the whole square root in there. And I get a value of 0.2280. Now, that value is pretty big. And remember, your book considers unusual values to have probabilities less than or equal to 0.05, which this is not. So this is very typical. What we're saying is we have about a 23% chance of getting what we got. That's not unusual because it's not less than 5%. So that's why we can say that we don't necessarily have evidence that the proportion has increased, because the value we got is the typical value to get.